We are going to learn arithmetic progression. So an arithmetic progression is basically a sequence where you will have terms which have a common difference between each consecutive term. So suppose you have 2, 4, 6, 8 and so on. So 2 and 4 have a difference of 2, and then 4 and 6 have a difference of 2, and you can see that all of the terms have a common difference of 2. And similarly, even this sequence is a AP because again there's a common difference of 0. So any sequence where there is a difference which is common between every consecutive term, so that will be an AP. So this is a special type of sequence. So in this type of sequence we'll have, like, we can generalize an nth term, and we can also find out the sum of all the terms till an nth term. So first we'll try to find out the nth term. So there's no need for this derivation, but since this is a short kind of derivation and it's easy to understand, that's why I've written this. So if you take the sequence, and I've written it down here again, so this is the first term, and I've considered A as the first term of the sequence. So A is here, A is 2 here, and I've considered the common difference as D, and these are all conventional notations that you will find throughout every book. So the first term is basically A, which I said. So the second term will be A plus D because you have a common difference of D. So this 4 will be A plus D. A is 2 and then D is also 2. So 2 plus 2 is 4. Then the third term will be A plus D again. So it will be A plus 2D. And then the fourth term will be A plus 2D plus D again. That will be A plus 3D. So you can correlate. So like the first term is A, second term is A plus D, third term is A plus 2D. So if you see 3 and 2, 2 and 1, and again 4 and 3, so whatever the nth term, then the coefficient of D is n minus 1. So from that we can compare, and we can generalize that the nth term of an AP will be A plus n minus 1D if we have to find the nth term of the AP. So that is that. And for the sum of n terms, again we have derivation, but that is not as simple and short as this, so I'm not going to delve into that. So I'll just write down the formula. So for that it is, so if you have suppose n numbers, suppose I tell you to find the sum of the first 10 numbers or the first 20 numbers of a AP, then n is that 10 or 20. So you have n by 2 whole multiplied by 2a plus n minus 1d. So this is one way to find it, if you know the number of terms, the first term, and the common difference. But if you're not given with the total number of terms that you have to find out the sum for, so suppose you are given only the last term and the first term, then you can use this formula as well. So here L is the last or the nth term of that AP. So that is about the sum of n terms of an AP. And you can also remember this property here that I've written down, that if there are three, if in any AP I take 3 consecutive terms, so they will obviously be in AP, that is for sure. And a relation between those 3 terms will be that 2b, like the middle term. So b is the middle term, so 2b will be equal to a plus c. Or you can also think of it like b will be the average or the mean of a and c. So yeah, that is pretty much the theory that you need to know about this chapter. And I've solved this problem so that you can have a better idea of things. So the question is that you have been given a sequence. The first thing that you need to do is that you have to show, or you have to prove that it is an AP, and then you have to find the 16th term of the AP. You need to find a generalized expression for finding any term of the AP, and then finally you have to find the sum of the first 10 terms of the AP. And the sequence given is 9, 12, 15 and 18. So the only way you can prove that a sequence in AP is to find every common difference and show that all of them are equal. So 12 and 9 it's 3, 15 and 12 is 3, and 18 and 15 is 3. So all of them are 3, and so we can say this, that it is an AP. So that is quite simple. And then they said that you need to find the 16th term of the AP. So as you have seen in the previous formula, that the two formulas that we have learned. So nth term will be a plus n minus 1 into d. N here will be 16 because you have to find the 16th term. A is 9, first term is 9, and d is 3. Their common difference is 3, as we have found out here. So we will just substitute the values and just calculate, and we'll get it as 54. It's very simple. And if you need to find they've said to find the general term. What do they mean by that is you have to find an expression by which you can substitute the value of n, and you will get, suppose, the first term, second term, and so on. So again, you just use the same formula that you've used for calculating 16 term, just that here you don't substitute n because you don't know what n is. You just substitute a and d. So again, here also a will obviously be 9 and d is 3, and just simplify the expression. You'll get 3n is here minus 3, so 9 minus 3 is 6, and you get 3n minus 6. So just in case you want to verify, suppose you want to find the first term, so if you put n as 1 here, then it will be 3 plus 6, that will be 9. You will get the first term. Again, you can verify for all the terms. You will obviously get every term of the AP. And finally, you have been told to find the sum of the first 10 terms. Again, just use the formula that I told. So here you know the number of terms, so you just use the first formula that I told. So n by 2, n is 10, so 10 by 2 into 2 into 9 is 9, and n is 10 here, not 16. So 10 minus 1 whole multiplied by the d is 3 here. Just simplify and you'll get 225 as the answer.